Hello, I'm Channa Bankapur. I'm a trainer at Master Technologies, and this video is being recorded for the YouTube channel of Master Technologies. And please do subscribe to the channel. Okay, I'm going to discuss my solution to today's problem in October LeetCoding challenge. Uh, the, today's problem is K-diff pairs in an array. So the problem is we have an array of some integers, and we need to find the kind of pairs where the difference is k, right? That's all we need to find here. These points actually just indicate that, and here a and b essentially means one of nums of I and nums of j, so that's what they meant by a and b here. So there are examples, some examples given, and I think there are enough number of examples to understand the problem, even the bottom cases of the problem. Suppose if k is 2, there are two pairs. One is 1 comma 3 and another one is 3 comma 5. Even though one repeats twice, we don't actually list 1 comma 3 twice because we need unique pairs, right? And so another special case is when k equal to 0, that's when we need the numbers which repeat, right? So that's why there is only one pair, 1 comma 1. Even if one repeats say 3 times, the answer is going to be only one pair, right? So that's, I think that's all about it. Let me take an example which helps me to uh, explain the solution I have in mind or my approach. So the example goes this way. Okay, so before taking that example, it is very clear that the order of these elements, if you just sort them or do something else, that doesn't matter. And sorting makes this solution easier. So I'm gonna sort it, right? My sorted array is gonna be something like this. So we have say 2, 2, 2, which appears 3 times, and then say 5 may appear twice, and then we have 6, 10, 11, 12. 13, and I'm going to skip 14, so I'll take 15. So this is my vector to start with, right? So if k equal to 0, the answer is only 2 because there is one pair called 2 comma 2 when k equal to 0. There is one pair called 2 comma 2 and another pair is going to be 5 comma 5. So the answer has to be 2 because there are two pairs. But if k equal to say something like 4, what should be the answer? In that case, first of all, we should get rid of these duplicates because they are not going to help us. So I'm going to get rid of this one and maybe another 5 here, right? So now the resulting array essentially has only one occurrence of each element. We need a pair, right? So what we can do is we can actually have like two pointers here. Maybe the first one is pointing to the first element and second one is pointing to the second element because we need a pair. And I make sure the first pointer and the second pointer is never going to point to an element to the left of first pointer, right? So that's what I'm gonna make sure. So here, so if the difference between these two elements, like 5 and 2 is equal to k, we got one pair. If not, what should we do? So then see, because the difference in this case is only 3, and to see if the difference is 4, we have to basically increase the difference. So decreasing the difference is not going to help. So that's why incrementing I is not going to help because that only can decrease the difference. To increase the difference, I2 should be increased. So that's why the second iterator or second pointer, I'm going to just increment it to next one. So that way the difference is increasing. So when difference is increased, we again see whether it is equal to k. If it is equal, we got one pair. So we got a pair here, which is 2 comma 6, right? And after we get a pair, obviously both of these numbers are not going to be involved in another pair because anyway there is no repetition. So I'm going to increment both. So now I1 is going to point to 5 and I2 is going to point to 10. Now look at the difference here. Now the difference is more than k. When the difference is more than k, if you increment I2, the difference is going to get bigger. So that is not what we want. So if you increment I1, the difference is going to reduce. So we want it to reduce because we are looking for k. So that's why I'm going to increment I1 to the next one. So which is 6 in this case. And again, we got a pair. So which is 6 comma 10. Now we are at 6, 10 and the difference is same. So I'm going to increment both as we discussed earlier. So this is going to be I1 and this is going to be I2. So the difference is lesser. So I need to increment I2. So I2 is going to keep going to the next. And even the difference is 2. So it is lesser. I'm going to keep going to the next. Difference is still 3, which is lesser than K. I'm going to go here. So now the difference is more, right? Instead of being equal to K. So I'm going to increment I to the next one, I1 to the next one. So now again, we got another pair, which is 11, 15. So now I'll increment both. I1 is going to go to this one and I2 is going to go to end. So when I2 reaches end, obviously we don't have a pair. I'm going to stop, right? This is the logic I'm going to use. So we got 3 pairs in this case. So the answer has to be 3 when K equal to 4, right? So let's quickly code this example. Right, instead of coding from scratch, I'm gonna just show my code and explain. All right. So we have. Let me zoom it a little bit. Okay. So we have this vector nums, and then we have k, right? So anyway, sorting is not going to hurt us. So we'll just start with. And when we sort it, if k equal to 0, we have that special case because that's the only case we need to worry about or care for the repeating elements or the duplicates, right? So if k equal to 0 and nothing else actually matters. So what I'm going to do is I'll just call some other method called find duplicates and just feed the vector. That should find the answer. Let's just try to understand that method first. So here what I'm trying to do is I start with result as 0. That is the answer I want to find out. And to start with I equal to 0, which is the index of the first element. And as long as it is last but one element, it is pointing to the last but one element. I keep comparing ith element with I plus one element. And if that is equal, I'm going to increment the increment this one, increment the result. And after that, we need to jump all of those duplicates. Suppose if a number is repeated more than twice, we should not be counting it more than once, right? So in our example, I had 3 instances of 2. So there is only one pair called 2, 2. It should not be like another pair. So if we have something like this, I equal to 0, 1, 2 here, and when I equal to 0 and I plus 1 is equal to 1, we got a pair, right? But we should not again count I equal to 1 and then I plus 1 is equal to 2. That is not another pair. So we need unique pairs, so we're not going to count that. So this while loop kind of skips them, right? So that's the idea here, and it's going to get the result. Now, if k equal to not 0, we don't need any of those duplicates. So what we are going to do is we are going to skip all of those things. So how do we skip it? I'm using this a function called unique. That's going to basically remove all of those duplicates, and it has only the unique numbers in the array. But yeah, array is not, or the vector in this case, the vector is not resizing it. So instead of looking at the end of the vector, we are going to look at an iterator called end iterator, which is returned by the unique. So now my effective vector is from nums begin, and then it's going to end before that end iter. So I can use end iter as good as the actual end end iterator for my purpose, right? So what I'm going to do is I'm using 2 iterators here. The first one is again that I1 what we were talking about, and second one is I2. So which is pointing to the first and second elements of the vector. So now, yeah, so I'm just using the same logic I explained. So start with the result as 0, as long as the second iterator, which is always ahead, uh, is not equal to the end iterator, which is what we found out from the unique. We keep doing this one. So we take the difference between those two values, right? I'm using star here to dereference. So I get the difference between those two values. It's always between the number pointed by iterator 2 minus the one with iterator 1, right? So if the difference is equal to k, so we got a pair. I'm going to increment the count, and then when we got that, we need to increment both iterators because both of them are not going to be involved anymore. And otherwise, if the difference is greater, obviously the first iterator should increment so that the difference keeps reducing it. So that's why I'm incrementing only iterator 1. If otherwise, in the last case, the difference is lesser than k, in that case, I'm incrementing iterator 2 so that the difference increases, right? So this is going to give me the result, and That's why the result has to be this one. Okay, so I'm just working with the same example I took, but yeah, just to show you, the unsorted array is not going to be useful. I just made little shuffling here, but it's not much, right? So if we run this one, it's going to give me the result, expected result. Obviously, it is going to sort first, and this 5 is going to be after these twos, right? Let me test for k equal to 0 also, so that the answer should be 2 instead of 3, right? The answer is 2 as expected. Let me submit it. It should work. Yeah, it worked, right? So it worked, and then it should run pretty fast. Yeah, look at this 99.95 percentile. That means this is the fastest implementation, right? So now to quickly analyze the time complexity of this, suppose there are n elements in the array, and the sort is expected to take big O of n log n time. And after that, either it is going to go to this method, find duplicates, or it's going to execute the rest of it, right? Depending on the value of k. And this one is clearly big O of n, because look at this, we have a while loop, and then every time I is incrementing once. What about the rest of it? This unique is also expected to run in linear time. So I'm going to take big O of n for that. And after this, it is kind of very clear again, this whole while loop is going to take big O of n time. So because in each of these iterations, either iterator 1 or iterator 2 are increasing, sometime both. So that's why it won't take more than 2n iterations, right? So that's why it's going to be big O of n. And sorting is kind of the most significant operation essentially here, right? So that's why the overall time complexity should be big O of n log n. All right, that's why it ran really fast, right? I hope the method is clear, and yeah, so make sure you give it a try before actually just copying this code. And if you have any comments, questions, suggestions, please let me know. They're always most welcome. Happy coding.